Hello, and thank you for coming along. Today we're going to discuss some notes from life on the edge, the geophysical fate of the post-Columbian city. Geologists tell us, and now citizens are aware, that the Pacific Northwest is due to have a major earthquake soon in geologic time. Furthermore, there are already some rather dramatic geologic events occurring all over the world, particularly in volcanoes on islands, like in La Palma, the island in the Spanish Canaries, just off the coast of Africa, where several quakes have been recorded, and there's a possibility of a tsunami emerging. Finally, we're going to consider what rising sea level will do to coastal cities. So we're looking at the geophysical fate of the post-Columbian city in the context of big transitions in human history. I mean, really big transitions. Transitions like the transition from the end of the last ice age, the transition in human civilization when agriculture became adopted and widespread, and now the transition that we have to face because of the geophysical fate of the post-Columbian city. Can humanity make the necessary transition in the time frame we have before us? Well, the answer is perhaps, but in order to survive, we need to undertake several transformations of our different cultures all over the world in a very short period of time. First, we must always remember that, as Will Durant, the famed historian, reminded us in the last century, civilization exists by geologic consent, subject to change without notice. This is what's become dramatically apparent in the Pacific Northwest from the recent studies of geologists. And it's now percolating down to the citizens level as efforts are being made to prepare for this major earthquake. Let's take a look.
In the Pacific Northwest, a slow-motion collision of tectonic plates along the Cascadia subduction zone has been building tension for over 320 years. And when that tension is released, the resulting earthquake is likely to be as large as a magnitude 9. That will be 45 times more powerful than California's most destructive quake in 1906, and the consequences defy imagination. This megathrust earthquake is predicted to be so significant, locals simply call it the Big One. And scientists estimate that it has an alarming 37% chance of occurring within the next 50 years.
The Pacific Northwest is due for a major earthquake.
These really dramatic events have happened in our past, and they will happen again.
Tony Johnson is chairman of the Chinook Indian Nation, one of the indigenous communities already preparing for the next big one.
You know, we spend a lot of time worrying about what's that going to look like. It's a really grave concern for us.
We really need to be prepared for that eventuality, because it's not a matter of if, it's just a matter of when.
These days, it may seem like earthquakes are not all that uncommon, due to frequent media reports
just into CNN, a very strong earthquake just minutes
and
ago.
lots of cell phone videos posted online. But it's actually been centuries since the contiguous US last experienced a truly big one, an earthquake with a magnitude greater than 8. The last one on record was the earthquake of 1700, with an estimated magnitude of 9. So, what caused this earthquake?
The biggest earthquakes in the world are along subduction zone boundaries, and those are places where one tectonic plate is diving down underneath another tectonic plate. The largest earthquake that's happened in the US that we're aware of was along the Cascadia subduction zone, where the Juan de Fuca plate is diving down underneath the North American plate. And we can get really big earthquakes there because the plate that's going down is usually oceanic crust, which is cold and dense. That means it can break. So if you think about baking chocolate chip cookies, when you pull the cookies right out of the oven, they bend and they're nice and gooey. But once they've gotten to be cold, they break. So that cold, dense crust that's going down can break for a much longer time. So we get bigger earthquakes in those particular places.
The same tectonic activity that caused the earthquakes resulted in another destructive event, a tsunami.
You have one plate diving down beneath another. This section gets locked and it pushes this part up. When the fault ruptures, when the amount of stress overcomes the friction, it bounces back, which lifts up the water above it and causes that water to flow out in all directions. And that water flowing out in all directions is the tsunami.
Clues about the earthquake and tsunami of 1700 can be found in these eerie-looking ghost forests.
And we have evidence of these submerged trees or the ghost forests in numerous places around our area, including at our traditional village.
These ghost forests formed when the area became submerged after being hit by the tsunami. Even after the tsunami receded, the entire landscape had actually dropped several feet, a result of the plate tectonic motion. Oral histories of the event suggest that many died in the tsunami, and Heritage and Cultural Director of the Shoalwater Bay Tribe, Earl Davis, explains how additional clues about life after this earthquake and tsunami were pieced together.
The archaeological record basically suggests that tsunami came, laid down a bunch of sand, and then people went back to kind of normal life. You can see it right in the soil. There's a layer of just sterile sand, and then there's an occupation layer immediately after. It doesn't appear like there was a huge rebuilding time for us back then.
For communities along the coast at sea level, an earthquake and tsunami event could have a much bigger impact today than it did in 1700.
Our lifestyle now is largely predicated on the modern, Western, colonialized type lifestyle of putting in a cement foundation and running all these utilities and building a big, expensive infrastructure that is supposed to be there for 200-300 years. Whereas traditionally speaking, we put some poles in the ground, covered them in planks, lived there for half the year, then packed up all the planks and went to where we had another house, maybe up to 100 miles away, to better fishing grounds or better grounds for avoiding harsher weather.
And the threat of another event like this is very real.
The geologic record tells us that there are large earthquakes along that boundary about every 300 to 500 years.
Which means we could be getting close to another big one.
We do not know when the Cascadia earthquake and tsunami will occur, but it could be soon. And we know that to some extent it's inevitable. It's part of an ongoing process in geologic transformation of plate tectonics on the Earth's surface. Geologists warn it could be soon. But how soon is soon in geologic time? 20 years, 50 years, 500 years, 5 centuries? Who knows? 5 centuries is a very short time in geologic time, but 50 years is something within our lifespans. In any case, other dramatic geophysical events are already unfolding before our eyes right now. Take, for example, Cumbe Vieja, the volcano on the island of La Palma in the Canary Islands in the Atlantic. There have been several earthquakes, and as of October 15th, the largest one was recorded, raising the possibility of a tsunami. Local populations gathered on the beach are quite alarmed and are being told to evacuate to safe spots in the island. You can hear the explanation from the Spanish geophysicists who've been keeping a very close eye on this.
Desde octubre de 2017 hasta junio de 2021, se registraron hasta 8 enjambres sísmicos en la parte sur de La Palma, en las Islas Canarias. El 11 de septiembre de 2021 comenzó un nuevo enjambre sísmico de baja intensidad en el sur de la isla. El lunes 13 se alcanzaron los 1.500 pequeños seísmos en la zona de Cumbre Vieja. El gobierno de Canarias activó la alerta amarilla, nivel 2 de 4. El 19 de septiembre de 2021 comenzó una erupción volcánica en La Palma.
Soy Manuel Calvo, soy profesor catedrático de universidad en el Departamento de Física de la Universidad de Burgos. De preparación soy geofísico y mi tema de investigación es el paleomagnetismo. Estudiamos rocas volcánicas a menudo, aunque no sea vulcanólogo, y en fin, voy a tratar de comunicaros lo que pueda decir sobre este asunto.
But the La Palma quakes and volcano have a larger significance than simply the tragedy and suffering for the local population. This has been made clear by the British geologist Bill Maguire in his discussion several years ago about this volcano on BBC.
As the forces within the volcano built up to the point where they will begin to overcome the friction forces holding the flank in place, the flank will begin to move towards the sea.
And then at some point, the rock will fail on a major scale. And this huge chunk of rock, maybe 20 kilometers long or more, will start to slide into the sea.
The waves initially here would be many hundreds of meters high, and those waves would all be moving out into the ocean, spreading out laterally, but with a lot of the energy heading across the Atlantic towards the coast of the Americas.
Looking down on it, it'll look unbelievable. It'll look as if the island is falling apart, generating these huge waves which are fanning outwards to reach the eastern coast of the United States.
The waves will take about 8 hours to travel between here and the coast of America. Just enough time to get the message out, to warn people that this event was happening. But unless evacuation plans were incredibly efficient, it would not be enough time to get everybody out of the affected areas. The areas at risk include cities like Miami, parts of Boston, the coastal areas and suburbs of New York.
We're standing on the beach in what is presently Miami. The very first effect you'd probably see is what we call a drawback. The ocean would suddenly just pull away. You'd see a tide, a low tide like you've never seen before in your life. It would be actually spellbinding. But in the background, you'd be seeing this wall, and it would keep coming at you.
This will be the biggest natural catastrophe in history. There's a problem with all major natural catastrophes. Because we've never experienced these things, we don't think that they're going to happen to us. We just ignore them. But these sorts of events have occurred throughout geological history. They're not going to stop happening just because we're around.
Moreover, these dramatic geological spectacles of plate tectonics and volcanoes are not the only problems we face. Some of the geophysical transformations that threaten our civilization at this point, we have created for ourselves. This is the case with rising sea level that will threaten all post-Columbian cities.
Picture a map of Florida, with its long sandy beaches and wetlands, or cities like New York, Venice, and Alexandria, all metropolises with some pretty watery boundaries. Now, try to picture what these might look like in 100 years. The Sunshine State might look very different than it does today. The same goes for Manhattan Island or Mumbai. This is our best guess of a warmer future, one where sea levels are gnawing away at the corners of our carefully drawn maps. Coastal cities are first in line for big changes, and some that can afford it are gearing up to spend billions to make sure they survive.
You might think of the great ice sheets in Greenland and Antarctica as giant banks of freezers. And we're running down those rows of freezers, unplugging them.
That's Ben Strauss, CEO and Chief Scientist of Climate Central. They're a nonprofit organization that researches and reports on climate change, including sea level rise. Researchers like Ben have concluded that the world is guaranteed to see 4 feet of sea level rise just based on greenhouse gases we've already put into the atmosphere.
Once we unplug a freezer, it's unplugged. You can't plug it back in, and it's going to melt.
That's pretty scary, especially if you live on a coast. And according to the UN, more than 600 million people live in coastal areas that are less than 30 feet above sea level. And any amount of further emissions will cause sea levels to rise higher, with scientists like Ben expecting a rise of 10 to 20 feet or more. Some coastal areas are already struggling. During some high tides in Miami, water already slides across city streets. This is happening now, and it's a physical sign of rising sea levels.
There are already neighborhoods in the United States that I know about where real estate value has evaporated because floods that used to be rare or non-existent now happen multiple times a year. It's a block here or a block there, but it's really affecting people.
Climate Central created a visualizer called Surging Seas to drive this point home. It shows how coastal cities will fare as the climate heats up. Look at New York, New Orleans, Shanghai, or Lagos, and you'll see how melting ice could push shorelines inland. It's one of a few projects online that are designed to make the threat feel immediate.
I think climate change tends to be such an abstract and distant-seeming problem for most people. We want to make it as real and personal as possible. People being able to look up their own neighborhood, their own home helps to do that.
Here in New York, the sea level is actually rising faster than in lots of other parts of the country. We did a whole video about it. Anyway, earlier this year, the city unveiled an ambitious plan to keep the lower part of Manhattan safe.
I often said after Sandy, you don't find a lot of climate change deniers in New York City.
They plan to fortify the city and may actually build out land into the East River by 50 to 100 feet. It's not the first time that New York has reclaimed land from water, but prior expansions were mostly done to increase living space. This one will be to keep the water away from our living rooms. The plan will cost an estimated $10 billion.
We can't overstate the disruption that it would cause to take no action, so we absolutely have to act.
Janie Bavishi is the director of the Mayor's Office of Resiliency. Her team collaborated on a big study that looked into the climate risks faced by Lower Manhattan.
So we didn't just look at sea level rise and storm surge, but we also looked at intense precipitation and extreme heat. Across the city, we're taking steps to address these multiple hazards and multiple risks that we face from climate change.
For anyone living near the coast, sea level rise presents problems. But for cities, the issues are really unique.
Imagine water pouring into the streets on a regular basis just during high tide. You open your door and you walk into a street filled with water. It would impact underground infrastructure that we rely on. Imagine subway tunnels getting flooded on a regular basis, or the foundations of buildings corroding.
In addition to building out into the river, the city plans to install floodgates at critical places that would flip up in a flood to keep water out of low-lying land. But for now, these plans are still just concepts. They aren't even sure how they'll pay for it yet. But private funding is still on the table.
We're not planning for development, but that also depends on whether or not we're able to get funding from the federal government. We'll have to figure out how to finance this. If funding doesn't come from the federal government, then development might be part of the solution.
Wandering around Lower Manhattan, it's spooky to think about how dramatically climate change could redraw these city blocks. And it's obvious that one threatened area here is driving a lot of the urgency: Wall Street.
So Lower Manhattan is an economic center of the city. 1 in 10 jobs are located in Lower Manhattan. 75% of subway lines go through Lower Manhattan. So we know that we need to protect Lower Manhattan in order to protect the economic vitality of New York City.
But in a lot of places in the US alone, extreme preventative measures like New York's are out of reach. 2 communities, one in Alaska and another in Louisiana, are relocating to get away from rapidly eroding coasts. And a 2018 study found that as many as 311,000 houses in the United States will be vulnerable to chronic flooding by 2045. In other words, climate migration is already a reality. And policymakers here in New York want to avoid the chaos that could come from displacing a city of almost 9 million people.
You can't just pick up and move a city very easily. And because cities are such important concentrations of human lives and economic activity, I think we will invest a great deal in defending them. I don't expect us to be trying to move Manhattan. I expect us to be defending it as vigorously as we can.
We might not have as much time to build out the barricades as you might think. While most projections focus on 2100, it's not like sea levels will wait to 2099 to suddenly attack. Water will trickle in slowly, seeping into our lives and disrupting infrastructure, property values, and coastlines in the process. It won't be sudden, but it will be fast.
It's the speed of change that I think is the most dangerous thing about it. A bullet isn't dangerous if I'm holding it in my hand or throwing it at you. It's the speed of the bullet that makes it dangerous. It's the speed of climate change and sea level rise which are going to make them dangerous.
The problem with our excessive use of carbon was clarified at the UN not long ago.
We're facing the fact that we've done cost-benefit analysis and looked only at the benefits, not looked at the costs. The whole carbon bubble, the carbon moment in human history, is one great big gaspillage of a resource with no cost accounted for in terms of its impact on a global functioning ecosystem. If those costs were internalized, you'd be paying $57 a gallon for gas, right? So yeah, we got to get the metrics straight, but we also just have to move off of carbon. Not because it's becoming more scarce. A few years ago, we used to think, and on one of the graphs I used, it was the peak oil question that was the great anxiety. We're going to run out of the stuff. Well, in fact, we're not going to run out of fossil fuels in any known future, especially with the new technologies used in fracking and the like. It's not the scarcity of the material, it's the impact of the material. We can't survive using that amount of carbon. Just on the post-Columbian city basis. Post-Columbian cities are those that were put in place after Columbus discovered, as it were, the New World. He didn't discover it because it wasn't lost, right? But in any case, the post-Columbian city was put in place, pretty much, at sea level. Because that's how he got here, right? On a boat. The post-Columbian city is under challenge. If you didn't see the graphic here, 1,400 cities in the United States alone. We can't survive in those cities with the combustion of terrestrial carbon. This is why the new movement that's emerging is called the carbon underground. We're trying to keep the carbon underground. And you start doing the metric for that, you measure progress in a very different way. Not how much carbon have you used, but how much have you sequestered? How much have you prevented from being used? Second point about other alternative energies, use the renewable ones. Don't fall into the trap of thinking that nuclear is a solution to anything. If you want to look at externalized costs, think about the tens of thousands of years of the waste products that you have to deal with. We don't even have human languages that have persisted long enough to label this stuff. Right? There used to be a department within the DoD, the Department of Defense in the United States, which is actually trying to think of symbol systems to put on nuclear waste dumps so that people would know after a nuclear exchange had occurred to stay away from this material because it was lethal, because the languages wouldn't be around anymore, right? We can't cope with the downstream impact of nuclear, let alone the downstream impact of carbon. So don't think nuclear is the solution in this. What you got to do is run the whole thing on the solar throughput. Now that means water, wind, tidal, micro, hydro, and the like. That is, hydro is a function of the water cycle, and you're placing yourself back into a solar-driven system. But the only, see, we've got the thing 180 degrees around. We think we live on a planet with infinite resources and finite energy. We're struggling over to control that finite energy. In fact, in America, it's so absurd. We think that the world doesn't quite get it. That's our oil in the Middle East, right? It's just a geologic mistake it's in the Middle East. But it's our oil. And we spend a few $1 billion a day sort of making sure the world understands that. It's our oil. We're on the wrong metaphor in the sense that it's not infinite energy that we have moved to, and we need to. The infinite throughput of solar energy. We're thinking we've got finite energy and infinite resources, whereas in fact we have finite resources and infinite energy. So this isn't just a slight correction in metric here and there. It's a compass question. Are we going in the right direction? Not, are we becoming more efficient in the direction in which we're going? All you'll do with that is sort of make extinction more efficient, which really isn't the goal.
As it was emphasized, it's the speed of sea level rise that makes it particularly dangerous for the post-Columbian city. Not only would the UN itself come under inundation along the East River in New York City, but places like Boston are completely built in their infrastructure at sea level. The airports, the subways, like those in New York, and much of the Earth itself is fill that has been placed there in the last 300 years since the city became a commercial node of exchange. All these cities are extremely vulnerable in the next years, decades, and centuries. The thought of building dikes around them is simply impossible. We can build defenses against extreme weather events, but not against sea level rise.